All right, fifth graders, I was trying to lighten things up over here because I feel like I'm in the dark, but that's okay. All right, so I am using today as a little bit more of a flipped classroom. I may or may not be in the room for this lesson while you're working. It just depends. So we are working on lesson 4 of module 10. I'm going to share my screen, and I'm going to ask you to start working on the Spark Your Learning and see what you can do. So I'm going to share that with you. You'll have it in front of you. And my mouse doesn't want to work. There it goes. And we'll talk about this together. All right. So I think that should be good. Here is your page. Let's do this. And let's do this. It looks a little dark there. Okay. We are representing and finding the number of equal size parts. So you're going to work on this. As you work through this video, there will be times when you're going to stop and you may have to answer some questions. So this is not just, sorry, I'm trying to fix my chair. There I am. This is not just you following along and writing the answers. You're going to be expected to answer some questions on your computer and some on your extra piece of paper possibly. So think about this. A nature preserve is 5 miles wide. A ranger divides the entire preserve into 1/3 mile wide sections for different tours. How many sections does the nature preserve have for different tours? So the preserve is 5 miles wide. The ranger is going to divide the entire preserve into 1/3 mile wide sections. How many sections would that be? All right, I'm going to ask you to pause right here and see what you can come up with, and if you have an answer. Because we have 5 whole miles, I'm going to show that in bar models. 5 whole miles. 1, 2, 3, 4, 5. So those boxes are representing the miles. He's dividing all of this into 1/3 mile wide sections. So each of these are going to be divided, each of the miles are going to be divided into thirds. Are you on the right track for this? How many sections does the nature preserve have for the different tours? Well, if we have 5 miles, each divided into 3 sections or thirds, how many sections is that total? Your answer should have been 15 sections. That would be available for the different tours. All right, so now we need to pay attention. If we have 5 whole miles, we've been doing models where we have maybe 1 mile that we're dividing, but now since we have 5 miles, we have to make sure we show those 5 miles and divide them into 1/3 mile sections. That's going to be the key here. All right, so if you flip over to the back, let's look at this next one. We have this same nature preserve that has a 3-mile long trail for bird watchers. Ooh, any bird watchers out there? I like to watch birds sometimes. The ranger divides the trail into 1/2 mile sections and names each section after a different bird. How many of these sections does the trail have? So let's fill in some of this information to describe our situation. The trail is blank miles long. Hopefully you remember. It is a 3-mile long trail, 3 miles. And the ranger divides the trail into what kind of mile sections? 1/2 mile sections. This can be modeled by the expression. We have 3 miles being divided by 1/2 mile sections. So how would we represent that on a number line? If our whole number is 3, just like in our other models, on a number line, I'm not going to draw individual boxes. Like I just said before with the Spark Your Learning, I drew those 5 boxes. On a number line, I'm not going to show different models like that. But if I use this as my model from 0 to what? Now this number line is going to go to 3. So I'm basically, if I would have on the page before taken those 5 models and just lined them all up touching one another like that. So same thing here. I can then divide the number line into 1, 2, 3 sections. And I have to think about, here's 1, here's 2. And I'm talking about halves. So here's 1/2. Here's 1 1/2. There's 2, and I have 2 1/2. So the dividend on the number line, which one is the dividend? 3 divided by 1/2. Our dividend is 3. So the dividend is represented by these 3 sections on our number line. All right. Let's put our line, meaning our number line, is labeled. I never remember one. I always want to put 2 L's in labeled, but there's just one. Labeled 0 to 3. So that's how we're representing that dividend. The divisor. We are dividing by 1/2. How is the divisor represented? We divided, we put each of those miles. Each mile then is split in half. All right. How is the quotient represented on the number line? If we were doing 3 divided by 1/2, the quotient would be the number of sections that represents the quotient. The number of sections on our number line, 1, 2, 3, 4, 5, 6, would represent the quotient. So each space or section. Each space or section represents, I'm going to put reps represents the quotient, which of course we know means the answer to a division problem. So our division equation, we had our expression, 3 divided by 1/2. Now we need an equation. If we have 3 divided by 1/2, we have 1, 2, 3, 4, 5, 6 sections. So the trail has 6 sections. All right. So I'm going to ask how you're feeling about that. It is a little bit different because we're starting with the whole number this time instead of with the fraction. So it is a little bit different. Please answer the next question seriously for me so I know what needs to happen in our next class time. And we're going to go on to page 255. Let's think about what we've been doing. John's lawnmower uses 1/4 of a gallon of gas each time he mows the lawn. John has 3 gallons of gas in a container. How many times can he mow the lawn before he needs to refill the container? So let's start off again. He uses 1/4 of a gallon. So that's important. He has 3 gallons in the container. So with that 3 gallons, we're going to take that 3 gallons and we're going to be dividing the 3 gallons, right? So I'm going to put our expression right here. 3 gallons divided by 1/4 is going to tell us how many times he can mow the lawn. So let's do this almost like we did our number line. Let's draw a nice big bar model. I almost said mar model. Nice long bar model. And let's show those 3 gallons that he has. So instead of doing 3 separate boxes, I just stuck them all together. And each of those he uses 1/4 of a gallon each time he mows the lawn. So he's using 1/4 right here. This 1/4 is one lawn mowing. One lawn mow. Okay, so he's going to keep going. He's got all these other 3, 4. I have to stop talking while I'm counting. He's got all those other gallons, and he's going to divide them into fourths. So each rectangle in fourths represents how much gas, as we've labeled, that he's using to mow the lawn. So if we count those equal parts in the bigger rectangle, we had 1, 2, 3, 4. Here was 1, 2, 3, 4. I'm going to extend those lines to show these were our 3 gallons. Gallon, 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 and then we divided them into 4. So our equation to model this, we had our expression 3 gallons divided by the 1/4 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what does that mean? That means he can mow the lawn 12 times before he needs to refill the container. So John can mow 12 lawns before refilling. All right. Again, think about that. How did it feel now this second time? This is new information. Please be honest with the next question. How did you feel about this next situation that we just did together with the model drawing and solving? All right. I would like for you to try the check understanding right now. And you're going to put in your answer for the check understanding. And then you're going to, after you put in your answer, you'll be able to check with me and my work. All right. So go ahead and do the check understanding and put your answer in. Says that Tim serves 1/5 of a pound of cat food each day from a 2-pound bag. How many days will this bag last? So he has a 2-pound bag. 2 is our whole number. I'm going to draw 2 separate boxes to show the 2 separate pounds. So we're taking that 2 pounds and we're dividing it by 1/5 to show how many days the bag will last. So here's all of our information that we need. So of course, I have to divide each of these into fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if I do that, how many days? Each of these sections will represent 1 day. So we have 5 and 5. So that bag should last him 10 days. Let's stop and think about reasonableness. Does it make sense that if he has a 2-pound bag and he's feeding a day, is 10 days a reasonable answer? I think it is. Pretty good. All right. That was the check understanding. You're going to go on to page 256. And for each problem, I'm going to ask you to put in your answer as you're working, and then you can come back and look at my answer to see if you were correct. All right, go ahead and start. What would be our division equation to represent the model? Hopefully you would see that we have 2 whole parts, and we're starting with our whole number now. 2 divided by, what were they divided by? They were divided by fourths. So 2 pieces divided into fourths would equal how many pieces? It should be 8. So that would be your equation. That's all you had to do there. Going on, draw a visual model to represent 2 divided by 1/6 and find the quotient. We're starting with 2 again. So I'm going to put 2 rectangles, and I'm going to have 6 pieces in each. All right, so if I have 2 whole parts and I divide them into 6ths, how many parts do I have? There are 6 here and 6 here. Our answer should be 12. Your model doesn't have to look the same as long as we got to the same answer. Okay. Go ahead and work on number 4. Put in your answer. Tyra has 4 liters of distilled water for a chemistry experiment. 4 liters. This is 1/5 of the amount she needs. Ooh, of the amount she needs. I love it. How much distilled water does she need? So we have 4 liters and we're dividing by, divided by 1/5. So how much does she need? If this is only 1/5, then we're going to need how much? 20 liters. And if you drew that out to the side, great. If not, that's okay. If you were able to just solve. All right, for number 5, there are a couple of parts. It's asking to draw a visual model. Your models are going to look different. Let's see how you do. Here I have 3, a whole 3. For this one, I'm going to draw one big model, and I'm going to extend these lines to show that that model has 3 whole parts, and we're dividing them in half. So if I have 3 parts divided in half, what do I have? Hopefully you said 6. If I have 2 divided by 1/3, let's do 1, 2, and divide them into thirds. I originally saw this as, I don't know what I saw, but keep going. And so if we have 2 parts and they're each in thirds, we have, again, 6. So when I read it earlier, I thought they were going to be different, but we get the same answer. So there you go. The models look different, though. Maybe that's what I was thinking. How are the 2 equations the same? Well, they're the same because we got the same answer or quotient. We got the same, I'm going to use a math word since we're doing math. We got the same quotient, which means each dividend is divided into 6 parts. So each time our dividend, 3 and 2, they were both divided into 6 parts. So 3 and 2 were both divided into 6 parts. It's a fact family, isn't it? 3 and 2 and 6. There's our fact family. All right. Well done. If you were not sure about things, I will be looking at your answers on Edpuzzle, and be sure to ask questions in our next class. I will see you then. I'm going to stop sharing my screen and see you later.